Okay, so hi dear students, welcome to lecture 2 of module 5. So we have been discussing about the about the belt drives, right? In particular, we were discussing about the flat belt drives. Okay, so we have seen the basic concepts related to flat belt drives. Now we'll go in detail, in depth about with the design concept. Okay, design procedure. We'll first of all we'll see the basic design procedure used for designing a flat belt, and after that we'll be solving a problem based on that standard procedure in the manufacturer's catalog. Okay, but before going to the design, you should know the certain design parameters. So that means what are we designing, right? So design actually, so we as we have already seen in our previous lectures, or in starting from the design of machine elements 1 itself. By the term design, we actually mean to find out the basic parameters or the basic dimensions of that particular component, be it rivet, be it welding, whatever it is. We'll be finding all the dimensions of the component, right? Which is subjected to, for a particular application, it will be having, we have to select a particular dimension. Okay, that dimension is selected based upon the kind of the external factors which is acting on the material, right? For example, the power which need to be transmitted and all. Right. So here also we are going to find out the dimensions of a flat belt for a particular dimensions and the type of the flat belt. Okay, type as well as the dimensions of the flat belt for a particular application. Right. Which is nothing but the power transmission. Okay, depending upon the amount of power to be transmitted or the distance to be transmitted and all, you will be selecting different types of belt. Okay. So 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 what are those design parameters as far as a flat belt is concerned, right? So for that, let us see what are the basic parameters, right? So this is a simple example for a flat belt. Okay, as you can see, there are different layers. Okay, so these layers are actually called the plies of the flat belt. Right. Now, so as I said, we'll be designing or we'll be finding out the basic dimensions. From the figure itself, it is very clear that all you have to find is the width of this one, right? So the first thing that you need to find is the width of, or actually one of the parameters that you need to find is the width of the belt. So obviously the next one will be the length, right? Oh, yes, it is the length. It is a part of the diagram only. The flat belt will be extending to a particular length to some longer length, right? So it is just a part. So I have just shown that one for your understanding purpose, right? So you need to find out the width plus length and yes, from the figure it is very clear that you should also find out the number of plies which you need, right? Which is the third parameter. Okay. Also you also need to find out the type of material or the type of belt. Okay, so these are the basic four parameters which you need to find out for designing a flat belt. Okay, starting with the type of the belt. Okay, the different we have seen the different materials or the different types of belt I have been using, and so based on that we'll be first selecting the type of the belt. Okay, then you need to find out the number of plies. Okay, depending upon the power to be transmitted, we'll find out the number of plies, followed by the basic dimension, which is nothing but the width and the length, right? So these are the things that we need to find out, or these are the basic design parameters. Okay, now for finding these parameters, we'll be going through a number of steps. Okay, to be exact, 7 or 8 steps are to be used to find out these parameters. So all other steps are actually a path to this, to finding out these basic dimensions and number of plies and all, right? So let us move on to the design procedure, right? Fine. So the first step, is a step-by-step approach. So let us start this with first step by step, right? Now, the first step is to determine the pulley diameters. Okay, since your flat belt is connecting two pulleys, you need to find out the diameters of both the pulleys. Normally, one of the diameter and the speed ratio, or whatever it is, will be given, or speed ratio, or the speed itself will be given. Okay, you'll get a better clarity when we are dealing with a problem, right? So use the speed. So in the first step, you need to use the speed ratio equation and find the unknown diameter which is not given, right? So all three parameters will be given. Okay, based on that, you need to find the dimension of the other pulley. So once you find the diameter, the next step is to standardize the diameter value. Okay, to standardize, there is a standard table in page number 7.54 in PSG data book. Okay, so you can refer to that table and you may standardize the value. We'll see that when we are solving the problem. Okay, we'll go to the page, we'll select the value and right. So the second important step is to calculate the rated or design load as per the formula. Okay, as per the given formula, and this formula, mind you, it is not the data book. You need to learn this formula. It's very simple formula. So first step, we have found the diameter, and followed by the next step is to find the rated load. Okay, it can be found out using this equation, that is design load in kilowatt is nothing but a rated kilowatt into load correction factor divided by arc of contact factor into small pulley factor, that is rated kilowatt into factor ks divided by k alpha into kd. Right. Now, so the rated kilowatt is actually is the power to be transmitted. Okay, it is the that will be given in the question, that the design power that need to be, or the power, the standard power as per the question, which is to be transmitted in kilowatt, is the rated kilowatt. Now the second value is the arc of contact factor. Okay, now to determine this arc of contact factor, all you need to find is the arc of contact first of all. Okay, once you find the arc of contact, you can find the arc of contact factor. Okay, now the arc of contact can be found out using this relationship, and this relationship is given in PSG data book 7.54. Okay, so once you find this arc of contact value, just below this equation there is a standard table, and from the table, for the corresponding value of arc of contact, you can select a standard k alpha value. So that is also there in page number 7.54. Just below this equation you can find that equation. Right. Now here, your capital D represents the diameter of the larger pulley, small d diameter of the smaller pulley, and C is the center distance. Okay, so once you have found out that one, the next factor is actually load correction factor and small pulley factor. So to find out this load correction factor, you may refer page number 7.53. Okay, you'll get a better understanding once we get into the problem. Right. Now after that, you have to find the small pulley factor. Actually this value ranges from 0.5 to 1. Okay, it depends on it actually depends upon the diameter of the smaller pulley. Okay, you may take any value between 0.5 to 1. That is not an issue. Right. Now once this is over, you can substitute all these values in the arc of in the design power, and you can find the design power. But once you find all other factors. Okay, just substitute those values and you can get the design load. Fine. So once you have found that, you can select a belt. Actually there are only two types of belt. You can refer the page number 7.54 in data book, and from that page you can see that only two types. One is Fort 949G and high speed 878G. Two types of belts are only there. Okay, so you may select any of the belt depending upon the condition. Okay, or you can select any of the belts. Since only two type of belt are there, you may select any of the belt, or in some cases your question will be specifying to select a high speed belt or a Fort belt and all. Okay, so depending upon the question, you may select the belt value. Okay. Now, after that, all you need to do is to find the load rating in V meter per second. Okay, so it is actually to determine the load correction. Okay, depending upon the material you have selected, you need to standardize the load rating. Okay, so for that there is a very standard equation. This equation you can find in page number 7.54, just below the material. Okay, just below this material you can find the value. Okay, so using that you can find out the load rating, which is nothing but load rating is at 10 meter per second into v by 10, where v is the velocity. It's actually the axial velocity, and that axial velocity you can find it by using this relationship. Okay, you need to multiply with 1000 because we are converting it to meter per second. Okay, because this one is load rating at 10 meter per second. Right, so once you substitute these values, you will get the load rating for that particular velocity. Okay, now all these things we were doing is actually to find out the belt width. Okay, because belt width is given by this equation, that is design power divided by load rating into number of plies. Okay, so in the previous steps we have found out this design power and load rating. So these two values we have found only for determining this belt width. Okay, so as I said, this is one of the main parameter in the designing of flat belt, right? This is one of the dimension of the flat belt, which is nothing but the belt width. So to find the belt width, you must know the design power and load rating and number of plies. Okay, so the design power we found out in the previous equations, right? So here using this relationship we found out the design load, and similarly your load rating we found out from here, right? So these two values, okay, already I have put a star mark. These two values we have already got, right? The remaining one is the number of plies. Okay, so to find the number of plies, okay, which is also one of the important parameter, right? So to find the number of plies, I'll go to page number 7.52. 7.52, there at the bottom left corner, you will be getting a table. Okay, so there, depending upon the minimum pulley diameter, okay, mind you, it is a minimum pulley diameter and the given speed velocity, which is the axial speed velocity, it is shown in the table. Okay, depending upon the speed, you may select the number of plies. Okay, I'll show all these things in the coming problem. Okay, so if you're using these values, you will get the number of plies. It will be 1, 2, 3, or 3, 4, or something, whatever it is, you will get the value, right? Okay, so once you are done, you may go to the calculation of the belt length, which is your third parameter, right? So it is pretty much simple. In page number 7.53, depending upon the conditions, you will get different length equation, right? Depending upon the condition, in the sense that there are open belt, similarly there are a closed belt and all. So depending upon the condition, depending upon the condition which is given in the question, you can select the length equation, and you may substitute all the values in that equation, and you can find the belt length. So once the belt length is found out, you may find the belt pulley width using the standard relationship, that is pulley width is nothing but belt width plus 13. Once you find this one, you have to standardize the value using the table given in page number 7.55. Okay, so this is it. This is the complete procedure. Okay, standard procedure. Okay, now let me summarize this complete procedure. Okay, it may look lengthy, but it is not. It is very simple procedure. Okay, now for summarizing, let me use this diagram. Okay, see. Okay, so we have a flat belt. Okay, so we have a flat belt. So to design this flat belt, all we need to find is the basic parameters, and as I said, the basic parameters, one of the parameters is the width. Okay, width W, other parameter is the belt length, and next one is the type of belt, and the last one is the number of plies. Okay, so these are the basic parameters, and to find these parameters we are using different equations. Okay, let us see what are those. Okay, so this is one of the important one, which is the width, right? Now to find this width, what we did was the standard equation for width, and mind you, it is not there in the data book, and you have to learn this equation. Okay, these two equations, design power uh, and the width equation, these two equations are not there. You must learn that equation, right? Now, the width is nothing but design power divided by load rating into number of plies, right? Now, so to find width, you need to know design power, load rating, and number of plies. Okay, to find the design power, you are going to this equation, which is nothing but design power is equal to rated kilowatt into these constants. Okay, now these two constants you will be getting from the data book. To get this arc of contact constant for arc of contact, you first of all need to find the theta value. For that you have a standard equation. Once you get theta, you will get k alpha, and you may substitute the value over there. Okay, so to find width, you need to find design power, and design power you can find using this relationship. Okay, the second important thing is the load rating. Okay, now to find the load rating, actually you need to find the type of belt. You need to select the type of belt, right? You will be selecting a type of belt. Now from that you will be correcting the load rating using this particular equation, which is load rating at that particular velocity is equal to load rating at 10 meter per second into V by 10. Correct. Again, if you know the minimum diameter and the velocity, you can directly find the number of plies, which is your next parameter. Okay, so once you get all these parameters, it is very easy to find the belt length, and that depends upon the question condition, whether it is an open belt, whether it is a closed belt and all, you may select the belt length. So as simple as that, it is very simple. Now with this basic understanding, let us move on to the uh, onto an example problem. Okay, and while going to this problem, please carry your data book with you, so it will be easy for you to understand the step-by-step procedure. Okay, so let us take a problem. Okay, the problem states something like this: you have an open flat belt drive, connects two parallel shaft. Okay, an open flat belt. Okay, this is one of the conditions. Open belt, this is an open belt. Okay, so that is one of the condition. An open flat belt drive connects two parallel shaft 1.2 meter apart. That means the center distance is 1.2 meter. Okay, the driving and driven shafts rotate at 350 rpm and 140 rpm. Okay, your rpm or the n1 and n2 are given. Okay, and the driven pulley is 400 mm in diameter, and the power transmitted is 1.1 kilowatt. Okay, so the first important thing that you need to do after getting the question is just make a rough sketch of the question. Okay, so as it is said, it is an open belt, right? So first of all, I am drawing an open belt system. Okay, and the smaller pulley is the driver is running at 350 rpm, and the driven is running at 140 rpm. Now, so therefore this is your n1 and this one is your n2. Okay, and in addition to this one, the diameter of this pulley is also given, which is 400 mm. Sorry, it is 400 mm, right? And in addition to this one, the power to be transmitted is given, which is nothing but the rated power, that is 1.1 kilowatt. Fine. Okay, so with this basic information, it is very easy to complete the first step, right? The first step is to find the pulley diameter, right? So the diameter can be found using the speed ratio equation, and once you substitute those values, you will get the value d1 as 160 mm. It is the step is very direct. You will get the diameter of this one. Okay, so I hope you understood the question. You have to design an open flat belt drive. Okay, open belt system. In a way, all what you need to find is the width of the belt, length of the belt, then the type of material or the type of the belt, and the number of plies. Okay, that's it, right? So for this particular belt, okay, all other details are given. So first of all, you found out the diameter. First one's diameter d1, and the diameter is 160 mm, right? 160 millimeter. Okay, so as per the design procedure, once you get the diameter, all you need to do is to standardize the diameter. For that, as I said, go to page number 7.54. Okay, so let us go to that page number. Okay, so this is that page of the data book, as you can see from here. Okay, now here, so this go to this particular table. Okay, recommended series pulley diameters and tolerances, page number 7.54. So from here you can check the diameter. Okay, when you're moving like this, you can see that 140. After 140, yes, 160 is there, which is what we have found out, right? So you can take the value directly. Okay, so that is a diameter. So I'm taking the diameter, which is 160 mm. Fine. So once you get that value, let us move on to the second step, which is nothing but the calculation of design power. Okay, so design power we are finding out to determine the width, right? So design power in kilowatt, this is the standard equation: rated kilowatt into ks divided by k alpha into kd. Correct. Now the rated kilowatt is given in the question. As I said, it is 1.1 kilowatt. It is given in the question. Correct. Now you need to take the ks value. We'll start with the constants. Okay, first of all, let us determine the ks value, and the ks value is nothing but I will take it from page number 7.53. Okay, so let us go to page number 7.53. Okay, so this is page number 7.53 of your data book. So here you can see a page where load correction factor ks. Okay, it is not written over there. You may write it as, you may take it as, it is only written load correction factor. It is nothing but ks. Okay, so there are different load correction factors starting from 1 to 1.5. It depends upon the different loading conditions. Okay, so as nothing is given in your question, you may take a steady load condition and the value of Ks is 1.2. So I have taken steady loading condition and I have taken that Ks value as 1.2. Okay, and write that condition whatever it is. Right. So the next one is arc of contact factor, which is K alpha. Right. Now to find K alpha, first of all, what you need to find is the arc of contact. Okay. So to determine arc of contact, you have a standard equation. It is given in page number 7.54. Okay. So let us go to page number 7.54. Okay. So this is your page number 7.54. Now, as you can see at the top of this page, you can see that equation, arc of contact equation. You can see it over here. So arc of contact is equal to 180 minus this equation. D minus D is the diameter of the larger pulley, small d is the diameter of the smaller pulley, and C is the center distance. Multiply it with 60 degree. Right. So equate this value with now find out the value of this arc of contact. Okay, so once you solve, you will get an arc of contact value. So just below this you can see a table for this arc of contact value. You can see some correction factor values. Okay, so once you get the value, just check in which area or in which region it is coming and select the value suitably. Okay, now let us see what we have done over there. Okay, now here for once they have found the arc of contact value as 168 degree, and for 168 degree your K alpha value from the table is 1.04. That's it. And the KD value, as I said, you may take any value between 0.5 to 1. Okay, on substituting those values you will get the design power, right? And the design power is given as 2 and on substituting all those values and solving, you will get it as 2.115 kilowatts, right? So this is it. We have found the design power, okay, which is the first step for finding the width, right? Now the next step is to find, or is the selection of the weld. As I said, we have only two types of weld. Okay, we'll see that. So let's go to page number 7.54 only, the same page. So here you can see there are two types of weld. One is high speed and the second one is 4949. Okay, so there are two types of weld. You may take any one as per the condition. Okay, if it is nothing is given, means you may select anyone. Okay, so for this belt there is a standard value, that is if for high speed belt it can take a load of 0.023 kilowatt per per ply. Okay, so it can only withstand this much load. If for a higher load you need to take a 4949, which can sustain 0.0289 kilowatt per per ply. Okay, so depending upon that you may take the type of belt. Okay, if nothing is given, you can take any of the belt, right? Okay, so here we have taken high speed 878G belting, and its capacity, as I said, it is 0.023 kilowatt per per ply. Okay, so the first important parameter is over, that is your selection of belt has been completed. Okay, so now depending upon this you need to correct the load carrying capacity, right? So the next step is to find the load rating correction. Okay, now as I said, so you can find this equation the same page, that is 7.54 itself. The load rating at V meter per second, or the standard equation is something like this: load rating at V meter per second is equal to load rating at 10 meter per second into V by ton, where V is your axial velocity. Now axial velocity you can find it using this equation. So it has been found, and it has been found as 2.9 meter per second. Okay, therefore corresponding to this 2.9 meter per second you need to find the load rating, right? So if you substitute that value over here, you will get the speed of the belt as 0.00667 kilowatt per per ply. Okay, so this equation you can find it over here on the same page. You can see that load rating at V meter per second is nothing but load rating at 10 meter per second into V by 10. Okay, now to determine V, you have to use the standard equation pi dn by 60 into 1000, right? So that is it. So with this, your load correction rating is also over. Now this is the second step towards finding the width, right? So the next step obviously is to find the belt width, right? So belt width is nothing but design power divided by load rating into number of plies. Okay, so to complete this one, so we have already found the design power and the load rating. So to find the width, all you need is the number of plies. Okay, So to find the number of plies, let us go to the page number 7.52 of your PSG data book. Okay. Now here, let us go to that page. Okay, let us go to the page number 7.52. So you can see at the bottom corner, there is a table. Okay, the minimum pulley diameter in mm. So all these values, the values inside here are the minimum pulley diameter values. Okay, so we have got the minimum pulley diameter value as 160. Okay, our speed value is 2.5, and that value is less than 10. So you just neglect that value. You can directly take the number of plies depending upon the minimum pulley diameter. Okay, so as you can see, the minimum pulley diameter that we have obtained is 160, right? Therefore, corresponding to this 160, the number of plies is actually 4. So directly select the value or the number of plies as 4. Okay, that's it. So the number of plies, so we've got the number of plies as 4, and substitute those values, you will find the width of the belt. Okay, so as simple as that, you will get the width directly. You have already found the design power, load rating, and number of plies we have selected uh, using your standard. Using the minimum diameter from the table in 7.52. Okay, now once you get the width, you need to standardize the width. Okay, for that, and the same page 7.52, you can see the same page 7.52, you can see the standard widths. Okay, so depending upon this 4 ply, okay, if we have selected 4 ply, so with respect to this one, since it was 77 something or 79 something was the value which we got, so the next value is actually 90. So you can select the value. Okay, but whenever you are selecting, just check whether it is coming under high speed. Okay, these sizes are available. So 1 star represents high speed and Ford, 2 star represents high speed only, and 3 star represents Ford only. So depending upon this condition, or depending, just check whether the star is okay, or it is satisfying your design condition. If that is fine, means you can take the value. So here it is satisfying, so you can take the standard value as 90 mm. Therefore the width of the belt can be taken as 90 mm. Fine. So once you have found the width, as I said, the next step is to find the length. Okay, so all other parameters, main parameters are over. Okay, now the only thing that is remaining is the length. Okay, now to find the length, as per the question, the question says is you design an open belt drive system, right? So this clue is given in the question itself. Okay, so there is a standard equation for open belt drive system. You can see from page number 7.53 in your data book. Okay, so from this page, let us see. Okay, so for the open drive, your L is nothing but 2c plus pi by 2 into d plus d plus d minus d the whole square by 4c. All these value, is nothing but the diameters and the center distance. Okay, now depending upon the other condition, for example, if it is a closed belt, okay, closed drive, select the next equation. Quarter turn drive means select the next equation. Okay, so depending upon the condition, you need to select. Right. So similarly, there are different other values also. If for some tricky questions, you need to select these values, check these values also. So be familiar with your data book page. Okay, fine. Now, so that's it. So with this, you'll get the length, right? And on substituting all these values, the length was obtained as 3,300 mm. Right. Now, with this step, your basic flat belt pulley design is almost over. Okay. The only thing that remains is the pulley width. Okay. Now, to find the pulley width, all you have to do is add 13 with your belt width. So you will get a value as 103 mm. But after getting this, all you need to do is to standardize the value. Okay. Now, to standardize, go to page number 7.55. So in page number 7.55, there is a table, recommended series of width of flat pulleys, right? So from this table, you may select the value. For example, you can see our value was 103, right? So okay, the value was 103. So let us select the value very near to this 103. Okay, so next value for 103. Okay, it is 103. So very next value or the standard value is nothing but 112 mm. Okay, so the width is 112 mm. Right. So I have not written over the, but you have to standardize the value, and the standardized pulley width will be 112 mm. Okay, so that's it. This is the basic design procedure for a flat bed pulley. It is very simple method, and only thing is that while going with a problem, while doing a problem, uh, one of the way in which a tricky question can be asked is, sometimes the question will be of the type that both the pulleys are rotating in same direction. For example, instead of stating a cross belt pulley, they will say that both the pulleys are rotating in opposite direction. Okay, and this can and both the pulleys can rotate in opposite direction only when it is connected in crossed belt pulley connection. So in that case, for length equation, you have to select the cross belt pulley condition. Other things will be almost same. Okay, that is it. So follow this procedure. The procedure is very important, and that's it. Thank you. And in next video, we'll be dealing with your design of V belt, and design procedure for V belt, and also a problem on V belt. Right. So thank you, and learn this well. And while doing this, always carry a data book and solve this problem first of all. Once you are okay with it, go with the other problems in your airwalk or whichever text it is. Okay, so thank you, Arnado.